We're not going to do any more in Chapter 1, since it's all history and theory and stuff like that. It's well worth reading, but it's not worth taking more time lecturing about. So we're going to jump into Chapter 2, where the meat of programming begins. And by the way, when you open up one of these PowerPoints or any PDFs or anything like this, just a reminder that if you download it, it'll look a lot better. D2L's got a preview mechanism in it, which will let you look at Word documents or PDFs or PowerPoints, but it's really pretty primitive and clunky. So you just click on the little thing to the side of the name of the document, and you can choose Download. And then you can open it, and it'll open it in the correct viewer for the application. Or if you scroll down to the bottom of the window, you'll also see a download arrow there underneath the preview. Come on. All right, Introduction to C. What we're doing is the parts of a C++ program. We've typed in stuff that looks a lot like this. I think it said hello world rather than anything else. But the first line here is a comment. There are two types of comments. There are single line comments that begin with // and then there are multi-line comments. Multi-line comments look a little bit different, and I'll demonstrate them as soon as I get Visual Studio up. All the comment is to document for you or for another program and looking at the code. It doesn't actually change the way the program works. It's like writing little notes in pencil on the side of the book to help you understand the program. And you say, well, I wrote the program, why do I need help understanding it? Well, if you program long enough, if you come back to something you wrote 5 years ago, it's going to look, like Greek to you. It'll be unfamiliar territory because the brain does not remember every single letter of every single program you've written. And if you ever pass your program on to somebody else to maintain or modify, then they won't have any clue of what it's doing without comments. So comments describe the program. What I would like for us to do is at the top of all of our programs that you turn into me, put a comment up there with the name and the date. And a description of the program would be really nice as well. If I want it to be any more complicated than that, I'll give you instructions. Did I launch Visual Studio? Then the next line is what's known as a preprocessor directive. What this does is that there's a file somewhere on the hard disk called IOStream. And #include, in other languages, it's called import. It takes this file and it inserts it into this file that we're looking at right now. So that when it compiles, when the compiler turns it into a program, executable program, it also has the contents of this file. And in this particular case, this file is what gives us the ability to use cout and these arrows to display stuff on the screen. If we did not include this file, if the contents of that IOStream file were not included in this program, we would not have the functionality that includes, which is the ability to read input or send output to the screen. And then there's this thing, using namespace. And I believe I've already mentioned that without that, we would have to preface a lot of things with std : in order for it to work. I'd have to put that there. So it just makes some stuff easier to type. And in every program we write, we'll have a main definition here. This is a function. The main function is what's invoked when the program runs. If we don't have a main, then the program can't run. The operating system can't find the entry point for the program to find it. It's like the front door to the program. If you don't put in a front door, then the program won't work. This is what's known as a return type. The way you define a function is you put a data type here, followed by a name of the function, followed by parentheses, and then followed by braces. And inside the braces, you put lines of code, one or more lines of code. Now this is a data type. INT stands for integer. An integer is a whole number, a number without a fractional component, like 1, 2, or 100. Not 3.1 or 10.001, or anything like that. No decimals. If there's a decimal point in it, it's not an int. Why do you define a return data type for a function? Because a function can return a value, and you can call functions from within other functions. If I want to get the value of pi, and I've written a function called getPi, then I could do something like this. X is equal to getPi, and it would return the value of pi so that I could store it in this variable. In order for that getPi function to do that magic of returning the value for us to use, it would have to have a return statement in it. In this case, this one has a return statement. It returns a 0. Main doesn't have to return anything, but if you make it return something, then this is much more common among Unix programmers than among Windows programmers. This is known as what's called as a return value. When your operating system runs a program, when the program is done running, you can check to see what its return value was. And typically 0 means it ran okay, and non-zero is supposed to be an error message. Now, we're not learning how to run these things from the command line, or write these into scripts where we would check the return values. So in this case, the fact that it returns 0 is really not very important, but we're just going to put it into our boilerplate. Know that this is the return code, and the operating system, after the program runs, could check, and it could do some behavior based on what was returned. So this is an input statement. No, it's not. It's an output statement. I can't read that. There we go. Cout stands for console output. In C++, these are known as streams. There's an input stream and an output stream, and this sends these words to the output stream. It's a strange way of talking about it, but we will use those terms over and over and over, the output stream, or I'll just call it Cout, usually for short. So this will send the characters, hello there, to the output stream so that they will be displayed. There are more than one kinds of stream. You can also have streams that are file, that save to a file so that you can print to a file. There are streams that represent internet connections. So if you wanted to send data to a server, you could do it that way. And then our return statement, and I already discussed what our return statement does. Every code block will begin with a curly brace and end with a curly brace. And they always have to match. You always have to have a matching number. If you have one opening block, you have to have one closing code block. Closing curly brace. And they have to be nested properly. So if you have a second one inside here, if something A is equal to 3, then do something else. Now we have 2 opening braces. We will need 2 closing braces as well. Here's our first opening brace. It's attached to the function. So this defines all the code for the function. And I know we can't quite read it because of that in there. And then this code block here is attached to the if statement. So it only runs if the if statement is true. And again, we have 2 opening braces, so we have to have 2 closing braces as well. And you'll get real familiar with the error message that comes up if you don't have the right number of closing braces, because it's a real common programming mistake when you're starting out. So special characters. I've already talked about what double slash means. That's a comment. The pound sign indicates the beginning of a preprocessor directive. There's more than one preprocessor directive besides pound sign include. However, I'm not sure we're going to hit any of them. People used to use preprocessor commands a lot more than they do now. In the C programming language was a lot more limited, and so people would use the ability to define macros with preprocessor directives. And that may sound like Greek, but what it meant is that you could expand the ability of C with new keywords or whatever by defining them with these pound sign commands. But C++ is such a robust language that people don't do that much anymore. Opening and close braces, brackets, file names are included in them. There's a special case, which is that if you write a file that you want included into the program, which is known as a header file, you will put it in quotes. If you put quotes around the file name, it means that that file is stored in the same directory as the program you're writing. If you don't put quotes around it, it means it will search its search path for the file. And what is the search path? Let me show you an idea behind the search path for those of y'all who are not familiar with the term. If I type set path in a command window, I see a list of all these directories. Now, any program that resides in any of these directories can be run from the command prompt. So I'm just going to try to pick one of these directories. One that's not too long. I don't know what this WBEM directory is, but here it is. It's in our search path. So if there are any executable programs in that directory, we can run them. Yeah, there are. I don't know what any of these do. I probably shouldn't run them. But if I type winmanagement.exe, since this directory here, this Windows System 32 WBEM is in the search path, then it will run it. It does something. Okay, cool. If the directory is not part of the search path, then I can't run it from the command line without giving it a fully qualified path. What is a fully qualified path? It's one that has the backslashes and the colon and stuff like that to define exactly where it is. So I have no idea where I could find a program that would meet that description. Let's look here. There's something called Sage here. Something called Peachtree. I'm just looking right now for an example to give you. Company. Yeah, there's stuff in here, but no executables. Anyways, if there was something in here, if I wanted to access this file here, and I was not in that directory, if I wanted to access, say, taxtable.dat was an executable file, it was a program. Then when I was somewhere else, then when I tried to run it like this, taxtable.dat, it would not run. It would not be able to find it because this directory is not in the search path. So I would have to qualify fully the file name. I would have to give the entire path to it. Sage, Peachtree, company, tax table. Now that's more of an operating system thing. That's not a C++ thing. But why am I saying this? Because in that # include, using angle braces means search the search path for this file. And it's a different search path. It's the include search path for Microsoft stores all of its files. And if you use quotes, it means it's in the same directory. Now the files that we import at the beginning are not going to be in the same directory. They're going to be stuff that Microsoft gave us. So we're going to use those angle braces after the include statement. Open and close parentheses. Whenever you call or name a function, you will have parentheses. Here's a function, main. When you call a function, you have to use the parentheses. So when I was giving you an example of writing a function that returned pi, when we invoked it, we would use the parentheses as well. So when I said x is equal to get pi, the parentheses mean that this is a function. If there is data that I want to pass to that function, I would pass it between the parentheses. Now get pi really shouldn't, it should always return the same value, so there's no reason to pass data into it. But say that you wanted to either get the value of pi either in binary or in decimal. We were talking about binary and decimal. So maybe we'd write the function so that if we passed in a 2, it would return the value of pi as a binary number. If we passed in 10, it would return the value of pi as a decimal number. And if we passed in 16, it would return the value of pi as a hexadecimal number. Now there's no such function, but we could write such a thing. Opening and close braces, I've told you what that does. That encloses a code block. That's the term I'm going to use a lot, but they're calling it a group of statements. This is a code block right here, from the opening brace to the closing brace. Here's another itchy-bitchy little code block. I didn't even put any code in it. We know what quotation marks do. If you have a string is a series of one or more characters, like a name, an address, something like that. You enclose them in quotes. For example, our program here that says hello there, that's a string of characters. So it's got double quotes around it. And then the semicolon. You use semicolons to mark the end of, I don't want to just say programming statement, although they do right there. but I guess that's what I'm going to have to go with. Not every line of C has to have a semicolon. You'll get real used quickly to figuring out which ones do have to have semicolons and which ones don't. Function definitions like int main do not have semicolons. If statements do not have semicolons. When we use while statements and for loops later, while loops and for loops later, they do not have semicolons. But things like that have a semicolon at the end. That one has a semicolon at the end. Pretty much everything we type, other than our boilerplate, will have semicolons unless it's part of an if statement or a function definition or a loop statement. You'll get real used to when you use it. Okay, the cout object. That displays output on the computer screen, and we've already done that. We did hello world. Here's another example. Programming is fun. If you put /n in there, \n, this is a special character which when it's displayed turns into what's called the line feed character, which is like hitting the enter on a typewriter. It just causes it to skip down a line. And if you put 2 /n's, it'll skip 2 lines. If you put 3 /n's, it'll skip 3 lines. So if I do hello world like this is all going to be printed on one line. I didn't mean to open the project. I made a classic mistake, which is to open the CPP file rather than open the entire project. If you open only the CPP file, you can't run it. So I'm going to open a project and find it that way. Here's one. So the file you want to open is called the solution file, the .sln file. That's the project. Other programming environments will behave a little bit differently, but that's how you do it in Visual Studio. Okay, so we have this program here. It does hello world. I run it. It takes forever to run. What are you doing? And it prints hello world. But if I put /n there, hello \n, it'll print those on 2 separate lines. Hello world. If I stick 2 /n's there, there'll be a blank line between them. So each time it sees a /n, it's like hitting the enter key. Bless you. So sometimes you'll see people use ENDL. You can do the same thing just by putting /n at the end. You'll see me mix and match both techniques up here. Basically, if I'm typing a string of text already, quite often I will just put /n at the end of it rather than have, it's easier just to tack those 2 things on rather than attack these, 6 characters in, including a space. Just get used to seeing them both.
Do we need to open this demo file?
No, you don't have to do that. You could open the Hello World project, whatever we called it, that we did on Wednesday. It was either in class C or in class 0. You can monkey around with it while we worked. That's all I'm doing at this point. You can send more than one item to cout. Here's an example of sending 2 words to cout. This is done in one statement. It's throwing 2 things into the output stream in one statement, and here is throwing 2 things into the output stream one at a time. This is kind of like just picking up 2 stones and throwing them with one hand into the stream, and this is like picking up 1 stone, throwing it into the stream, and then picking up the second stone and throwing it into the stream. Now maybe that's a really dumb simile, but this would do the same exact thing. This would print 2 words. Since there's a space there, there would be a space between the words. It would say hello space there. If I took the space out, it would say hello there, all in one without a space between them. If I wanted these to appear on separate lines, I could do hello \n, there, \n. I think I'll actually put that one into that program I was monkeying with. There we go. Hello \n followed by there \n. That'll print 2 different lines of code. Or 2 words. One per line. Is there any reason why you would do that like this? No, not really. But you might have other data that you want to print out that's part of a string. Now, there's no reason we wouldn't do hello backslash then in there backslash in all in one string like this. But what if we had a number or something that we wanted to print out as well? Say we had defined a variable called x and we'd given it a number and we wanted to print that out as well. Then we might do something like this. X equals, like that. Now we are sending three things to the output string. We're sending this string, the words x equals. We're sending x, so it'll print out 12. And we're sending the end of line character, which is just the same thing as if I'd done quote backslash in quote. But it looks prettier if you see ENDL. So when I run it now, it'll say x equals 12. There we go. Or if I didn't feel like mixing all of that on one line, I could do those in 3 lines. I could say cout x equals. I could do cout x like that. And then I could send out an end of line mark. And it's going to run the exact same way as it did before. No difference in its output. X equals 12. ENDL. It's called a manipulator. ENDL will start a new line of input. It's just like hitting the enter key. It's like that backslash n. Programming is ENDL fun. So when it prints out, it'll print programming is on one line and fun on the next. Just like that. You don't put quotation marks around ENDL. However, if you wanted to use backslash n instead of ENDL, you would put quotes around it. I could go back to this program and instead of ENDL, I could do cout quote backslash n quote, and it would do the same thing as the ENDL did. When you put / in front of a line, it's called commenting out. Commenting out means I turn this line into a comment. This code is now ignored. It's no longer going to send this to the output. I do that when I want to keep that line around because I may want to put it back into the program later. Or if I want to be able to compare what this one looks like with this one. You know, these two commands do the same thing. I left this one in as a comment so that I could point those two things out and show it. Sometimes I'll say that. I'll say comment out this line, and I'll come up here and I'll do that. That just means remove it from the program without deleting it. It's not part of the program anymore. It's like a label stuck to the program. The program's going to keep running, and it's going to run without that line in it. So if I run it now, it's not going to say x equals. It's just going to print out 12 because we define x as being 12 here. It skips this line, and then it's going to print 12. If you want to comment out a whole bunch of code rather than just one line, there's something called the multi-line comments. Multi-line is when you use a /* to mark the beginning of your comments, and then */ to mark the end of your comments. And everything between those two things is now commented out. That's why it's all green. Now the program's not going to do anything. We commented the whole thing out. You're never going to comment out your entire program, but that's just to show you. So when I ran it, it didn't do anything. In fact, since I commented out pause, it didn't even execute the pause statement and say hit any key to continue. So if we were going to keep track of things that we have learned so far, # include. This is a preprocessor directive that imports the specified file into the file we are currently compiling. And what do I mean by import? Well, all of the contents of IOStream will be included in the file at that spot when we compile it. We don't see it, but it's there. If I highlight the word IOStream, double click it, and then I click Open Document IOStream, we get to see the contents of that IOStream document. Really not very much. Stuff we don't learn. It's got all sorts of preprocessor directives in it. #pragma, #ifndef, all that kind of stuff. But when it runs, it's just like, or when it compiles, all of that was in that file. So what that import does is effectively puts all of that stuff in up at the top of our program so that we can use any of the functions that are defined there. We wouldn't want to have to copy and paste all that stuff into our program every time we wanted to use C in and C out, so we use the include instead. So what do those two things do? What do those indicate?
Code block.
Yeah, that's a code block. Which are lines of code considered. I can't come up with a better definition for it than that right now. Which are lines of code attached to a function name or a logical construct like an if statement or a loop. Sorry to use the word logical construct, but anyway, so if we're going to define our own function, like this, int my function, we have to put opening and closing braces here. And this is going to be, I don't know what this function does. Int x is equal to 1 plus 2, return x. There, now we've written a function. And it's got 2 lines of code, not counting the comment as its code block. You can embed code blocks within code blocks. I'm going to write another function called another function. This one is going to say int x is equal to 1 plus 2, and then we're going to have an if statement. An if statement checks, and if the whatever is within the parentheses is true, then and only then will it execute the code block. So if x is equal to 3, then C out x is 3. Like that. So here's an example of a code block. It was only one line, but still it's a code block that's nested within another code block. All of this is part of this function, but this is just part of that if statement. There's a fancy word for that. This code here, this code block, is subordinate to this if statement, and this code block here is subordinate to that function name. I really am not going to use that very often, that term. What else have we covered? We used those things. When you use #include, you can enclose the file name either in angle braces or in double quotes. #include standard IO. That's not right. IO stream, or #include myheader.h. Using quotes indicates that the file specified is right in the same directory as the file we are editing. Using angle braces indicates that the file is in another directory that's part of the C++ search path. Here's another thing. \n is the same thing as endl. It displays a line feed which causes the output to go to the next line, like hitting enter on a keyboard. /n. And whenever you see anything that begins with a \, that's known as an escape sequence. And the reason for that is kind of musty. lost in the history of time, but what it means is that it's changing modes. Here we're printing out letter by letter. But then when we hit the backslash, we're saying, oh, by the way, we're going to do something else completely. We're escaping the text mode, going into a different mode. And so that's where it will pick up the meaning for \n, which is the character term, the line feed. So whenever you see /n, if I call it an escape sequence, that's all it means, is it's something that's preceded with a backslash. There are several others besides \n. There's \t, which means tab. There's one which will ring the bell, and the buzzer inside your computer. I forget which one that is. There's a couple others. We'll probably see a list of them later. So here we go again. Programming is \fun. So it prints out programming is fun. #include. I've talked about #include already. It's called a preprocessor directive. It's not actually part of the C++ language. What that means is that C++ is defined by the keywords of the language, which are things like if and while and stuff like that. #include is not a word in the C++ language. It is used by the compiler, though, to do that file import. You should put it up at the top of your program, and you don't put a semicolon after it. It's just not a C++ statement. Variables and literals. What is a variable? A variable is a storage location in memory. It has three things. This says it has two, but it has three things. A variable has a name. It has a type of data it can hold, and it has a value. So if I define a variable named x, and I call it an int, and I store the value 3 in it. It's got those three things. It's got a name. The variable's named is x. It's got a data type, int, which is a whole number. And then it's got a value, the number 3. And it has to be defined before it can be used. So if I go into my program here, let me uncomment all the changes let me undo all the changes I made here. I'm going to change this line. Well, I'm going to comment it out. Here we go. X is equal to 12. That is no longer going to work. It's indicating it's no longer going to work because it's underlining it. It says X is undefined. It's not a variable until it's defined. How do you declare a variable? You give it a data type. So somewhere before this, before we assign a value to it, we have to just say what kind of data it is. Here we're saying it's an integer. Now that we've given it a type, we can store data in it. Why is that necessary? Because you can't store different data types in the wrong type of variable. Like if I have a string here, my name is Slim. There we go. Can't do that because this is not an integer. An integer is a number that has no decimal point. It's certainly not a string of words like that. So again, it's telling me, it's flagging this as an error with the little red underline because I'm trying to store the wrong type of data in it. So to get it to work, I have to declare the variable and I have to give it a value. You can do that on one line like that, or you can do it on 2 lines. And it's called variable because it varies. It can change. I can turn around and give it a different value later. If I feel like putting in 100 in it, I can do that. If I feel like saying x is equal to x plus 1, that's also totally cool. So if I printed it out again after those 2 statements, what is x going to equal? Well, it was 100. Then it equals 100 plus 1, and it stores it back in x. So what is 100 plus 1? It's 101. So it's going to print out x is equal to 101. It does both things, actually. It does the 12, and then it does the 101.
But if you did a return statement to that line, would it keep adding ones? Like return 15?
No, the return statement doesn't control that. The return statement is just what it's supposed to do on the way out of the function. So once the function gets all the way to here, then it's going to pass this value to whatever executed this function. So we could say return 10 million, and it's not going to change the way this program works. It'll still just print 12 and then 101. For now, just take it on faith that main needs to return a value but what it returns is not important to us, which is why I make it return 0. Good question. So let's put into our notes that a variable is a named location in memory that has a data type. Well, let's leave it like that, but then say it has to have 3 things. A variable has 3 traits, attributes. It has a name, it has a data type, and it has a value. So if we say int x, x is equal to 3, the name is x, the data type is int, which is short for integer, and its value is 3. There are other data types as well. There are strings. String name. Name is equal to Bob. So the name of this variable, let's make it first name. The name of the variable is first name. The data type is string. And its value is Bob. And so on. I'm not going to list a whole bunch of different samples because you get the idea for that really fast. Here's a variable definition, just like what we did. Int number. We have defined the variable. Some texts call it declaring the variable. That is defining the variable and giving it a data type of int. And then we say number is equal to 5. And then we use the cout to display the number. That's pretty much what our little sample program did. There are other kinds of data besides variables. There are literals. A literal is a number that is typed into the program's code. I have a couple of literals in my program here. This is a literal right there because it's typed into the code. Some people call it hard coding. I've hard coded the number 12 into the program. What does that mean? Well, instead of hard coding the number 12, I could ask the user for a number and let them type in a number. Then it wouldn't be 12. It'd be whatever they wanted to make it. But it's hard-coded to be 12 here. That's a literal. This is another literal. This is known as a string literal because it's a string of characters. String of characters are included in double quotes. There's another literal. There's another literal. There's another one. That one. There's another string literal. That's a string literal. And one last string literal right there. It's a weird term. Won't use it too often. But it's either a number or a string that is written into the program's code. String literals have to be enclosed in double quotes. Integers don't. And it could either be an integer literal or it could be a floating point literal. A floating point literal has a decimal point in it. So 13, like 12.1 would be a floating point literal. It just means data that is typed directly into the source code of the program rather than read from the file or prompted by the user or something. 20, that's an integer literal right there. And in the meantime, that's a string literal, and that's another string literal. You can store a literal in a variable if you're going to do something with it. Here we're taking this 20 and we're copying it into a variable called apples. And then maybe later on we'll do something with that number. We eat an apple, we'll subtract 1 from that value. Yep, these are the string literals surrounded by double quotes. X equals 12. 12 is an integer literal. Name equals Bob. Bob is a string literal. It's literally encoded into the program, man. Identifiers. An identifier is something that the programmer gets to define. The word if, we don't get to define. That's already part of the C language. But things like X and name and main, those are things that we define. The programmer gets to pick them. So here, where if I say, int age is equal to 43, 45, I don't have to call it age. the program would work just as well if I called this one Fred Flintstone. Now that's an absurd name for a variable, but it'll work as long as everywhere I want to use that variable I called it Fred Flintstone. Let's change X instead. So if I come up here and instead of calling this X, I call this Fred, and everywhere I referenced X, I instead made it the word Fred, that's totally fine. It would work perfectly. Then I redefined it back to being X because I didn't feel like changing all of those. So this is what's known as an identifier. Identifiers define either variable names or function names. That's a function. That's an identifier. We could call it anything we want it to, although it has to be called main for the program to run. Otherwise, the operating system doesn't know where to start running the program. That's a variable name. It can also be anything that we want, within some limits. There are some limits. You can't put spaces in identifier names. If I wanted to do this, int age is equal to 12, I can't do this. I can't say my space age. A variable or a function, any identifier cannot include a space. If it sees a space there, it thinks that you're entering a separate command. It thinks that there's 2 words here rather than 1. So that's one limit of an identifier, a variable name or a function name. Another is that you cannot create an identifier that begins with a number. So if you want to say 1984 tax rate, that won't work because it starts with a number. You'd have to say like tax rate 1984 or something like that. This is legal, but putting the number at the beginning is not. So an identifier is a programmer chosen name for a variable or function. There are some naming rules. No spaces. First rule. So you can't do user space name is equal to Bob. You have to say instead username is equal to Bob. So that's wrong. And this is right. What was the other rule that I just mentioned besides the spaces?
Numbers first.
Yeah. Can't start a variable and identifier with a number. $1984 tax rate equals 0.15. That's wrong. Tax rate 1984 would work. Beyond that, there are a few other rules. There are symbols you can use and symbols you cannot. You can use dollar signs, underscores, maybe a couple other symbols, but that's about it. As well as digits and letters. Naming variables. Naming variables is important because you can communicate the meaning of the variable by what you call it. If I called it Fred Flintstone, you're not going to know what it meant. But if I call it username, you know exactly what it means. If I called it x is equal to 0.15, you don't know what I'm using x for. So when you're trying to read the program, it's hard to read. But if I called it tax rate 1984 is equal to whatever, then you know that I'm talking about a tax rate. So picking a variable name is pretty important. You don't want to pick single letter variable names. You don't want to keep doing what I'm doing, which is just using x, because that doesn't tell you what that number is. The exception are for counters. If you're just counting a series of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that, yeah, sure, a variable name, x or I or whatever is good. But if it contains data that's more complicated than just a series of numbers like that, you ought to give it a good name. And there are like all sorts of choices you can make when you create a variable. I could do this, string username. Or I could call it string username with a cap. Or I could call it string username with a capital in the middle. Or I could call it string user underscore name. Or maybe I like capital letters, username. Or maybe I don't want it with that underscore in it, username. You just have to kind of pick a style and go with it. Nowadays, this is the most common style, where if you have more than one word in the variable name, you capitalize the second word and the third word and so on, and otherwise you use all lowercase. However, underscores are pretty easy to read. And in the 70s and the 80s and the 90s, there were a lot of people who used underscores an awful lot in their naming conventions. It's just kind of a fashion. Nowadays, this is the fashion, to do it that way. So if I was going to use that technique, you know, and I had something with 3 or 4 different words in it, like floating point, patient, body temperature in Celsius. That's a bit silly, isn't it? That variable name is too long. But it certainly does get the point across of what it is. It's a lot better than just calling it P or T or something like that. Don't make variable names that are that long. That's absurd. But I wanted to show you the using the capital letters in the middle of it. This is what's known as camel case. Camel being like a, you know, the humped creature that lives in the desert. Why did they call it camel case? Because the word has humps in the middle of it. Every time there's a capital letter in it, that's a hump. And I'm sorry, I didn't make that up. But camel case is the prevailing trend in naming variables nowadays. I'll just put a mark here that's saying this is known as camel case. And I'll put another mark down here that says camel case is now the fashion. It's all the rage. Just kind of pick one style and go with it. And if you're modifying somebody else's code, follow their style. And if you work at a business, find out what the other programmers do and follow it. In this class, I don't really care, as long as you give them good variable names. You don't just use single letter names all the way through the program. So I mentioned keywords. This is the vocabulary of C. You cannot use these as variable names. Usually you don't want to, but I couldn't make a variable called friend, which is because friend is one of the key words in the C++ language. These are all the, this is the vocabulary of the C++ language. It's every word that has a reserved meaning to the programming language. So we can't redefine it to be our own thing. Now looking at this, I don't know what half of these are. You're not going to know what every single one of these are. Just because a lot of this is either advanced stuff or it's stuff kind of left over from earlier versions of the C language or whatever. But as we go, we'll learn a lot of what these mean. There's some that we'll probably never hit, like decal type or static assert, or thread local. We're probably not going to hit these things. Or equal. I have no idea what that one does. That's kind of cool to see something there that I just flat out don't know. So if I tried to use any of these as a variable name, the program would not compile. So like if I try to make a variable called if, it won't run. Or if I try to use the word or is a part of the C++ language. So that should not run. No, or is not part of the C++ language. I'm sorry, but there we did see this. Well, it says it is. What happens if I try to use it? Huh? What do you know? Okay. You're not supposed to use keywords, and usually it won't even let you compile. We'll add that to our notes. Identifiers should convey the meaning of the variable or function. They cannot be one of the reserved C++ keywords, like if. Or while. Let's look up here. There's some other keywords. This is a keyword, using. So I couldn't make a variable called using. Namespace. I couldn't use a variable called namespace. Most of the stuff you'd never want to, wouldn't even occur. But there's one language that I teach where sum is a keyword. And it's a real drag because that's an awesome variable name. I want to use it all the time. I'm summing up a whole series of numbers. I want to use that as my variable name. I can't do that in Python. Well, I can do it in C. Alrighty, variable names. The variable name should represent the purpose of the variable. For example, items ordered. The purpose of the variable is to hold the number of the items ordered. Well, it doesn't really strictly tell us that it's the number of the items ordered, but it's pretty clear. And if we did see the data type in front of it, int items ordered, we'd be pretty sure that we knew what that meant. The first character of the identifier must either be an alphabetic character or an underscore or a dollar sign. The dollar signs are also legal, although they don't mention it. Dollar signs make the program look pretty weird. If you do that, people are going to think that you're programming in an insane alien language. There are some languages where the dollar sign has a very specific meaning. In old versions of the basic programming language, a dollar sign was how you defined a string. Yeah, it's just kind of a historical oddity. You don't tend to see them in variable names, but it's still a supported character for them. After the first character, you can use alphabet characters, you can use numbers or underscores, or dollar signs. I don't know why this author left them out. And then upper and lowercase letters are distinct. They mean two different things. If I call this variable tax rate down here and then I try to print it out, I have to use the exact spelling. I can't put a capital T here. This is correct. This would be incorrect. It's underlining it because it doesn't know what that is. It says it's undefined. So the letters have to be in the exact same case, uppercase or lowercase, in which you defined it. Case is important. You must use the exact case, upper or lower, that was used to define the identifier. That also has a few weird side effects. That means that lowercase x means something other than uppercase. I've been using this variable x up here. Later on, if I come down here and I say x is equal to 10, that's not going to work. But I could have two variables going on. I could have lowercase x and I could have uppercase x. And that's really obnoxious. Never use two variable names that are the same except for the case of the letters, because it's really confusing. Another is don't mix up your ones and your lowercase l's in such a way that, you could define a variable called x1, and then you could define a variable called xl. They look almost exactly the same. So in your program, if you said xl is equal to 10, and then later on you said x1 is equal to 5, you would think, you couldn't tell which one you were changing, or you might think they were the same thing. So just use some common sense. Don't use variable names that are the same except for the case, and don't make it to where lowercase l's and ones look the same. That's one reason I don't like ENDL, is a lot of people start typing END1 just because it's what it looks like. But once you realize it means end of line, then that kind of clears that up in your head. So valid and identifier names. Valid names. Let's pick which of these are valid and which ones are not. And this one uses a dollar sign, which the programmer says I think is invalid, the author of the book. But it is not invalid. It's actually valid. But does that one look good or bad according to our rules?
Good.
That one looks good. How about that one? Also good? That one. Nope, you can't have a period. You will see some syntax that looks like that, but it's not a variable name. The period actually separates the two things. It's like putting a space there, but it has a different meaning than a space. How about that one? And there's a problem with that one. What's wrong with that one? Starts with a number. If we called it fourth, spelled it out like that, that'd be okay. And this one, I believe it says it's wrong, but it's not because dollar signs are legal. See? Oh well. No author is perfect. Why don't we take a break here? If you need to get a Coke or use the bathroom or something like that, we'll be back in 5 minutes. So return here at about 8:25. So this one's going to be kind of a guessing game. It's not going to be a very fun guessing game, but it's going to ask you for a secret number, and if you type in the correct secret number, it says you win, else it says you lose. That's pretty basic. It's not very fair because it doesn't loop and let you guess over and over or whatever. It doesn't pick the number randomly. It picks the same number every time as a secret number, but it's a start. So I'm going to choose New Project. It's going to be an empty project. I think I'll call this one, I don't know, my initials, JT, and then followed by guessing game. Save my changes to the following items, sure, why not? So it closes that last project, it creates a new one. And I'm going to have to do right click on the source files and do add new item. Choose C++ file. I could call it anything I wanted to. Source is as good a name as anything else, but I'm going to put my initials in it. JT guessing game. So I now have a CPP file name that matches the name of the project. It doesn't have to, but okay, and there we go. Now we need that boilerplate code. You could go and copy it, or you could just type it in again. What do we always start them off with? A # include IOStream. And then after that, a using namespace std semicolon. Then we have int main. We're defining a function called main. And so after the word main with the parentheses is our code block. And I'm just going to stick return 0. That's our boilerplate that we'll be putting in every project pretty much. Alright, so we need a variable to hold a secret number, and we need a variable that will contain our guess. So secret number is going to be 5. Int secret is equal to 5. And we need another variable to hold our guess. Int guess. We don't need to put a value in that one because that is going to be filled in by what the user types. So first we need to tell the user what to type, so we have to use a cout statement that displays some output. And we're going to say, please guess a number. \n. And then we will use CIN to read in their guess into that guess integer. Now we need to check to see if that guess equals the secret. So we're going to use an if statement. We're comparing the value of what they just typed in, guess, to our secret number. So if guess equal, you have to use two equal signs there, is equal to secret, then print, you win. Else. Now I'm going to make a few changes here just so I can get more code on the screen at the same time. I'm going to start putting the opening braces on the same line as the statement that precedes it, like that. And the reason I'm doing that is just so I can get more code. And so after that last brace of that code block for the if, I'm going to add the word else, and then a brace, and then C out, and this time I'm going to display the message you lose with a /n. And again, I'm going to move it so that that opening brace is on the same line. That way I can get most of the code on one page up here. You don't need to do that. All right, there's my entire program, not counting that include statement and that using up at the top. I should run it and see if it works. It says guess a number. I'm going to type in 10. Well, I didn't get to see whether it worked or not. I left one thing out of my boilerplate. What did I forget?
Pause.
My pause, right. So above that system statement, I need to enter system, quote, pause. And you only have to do this if you're doing it on Windows. If you're a Mac user, you leave that line off. So I ran it, I typed in 5, it said I won. Now I want to test both paths. There's two paths through the program. You could either say you win or you lose. I've only tested it to get one of those answers. So I'm going to run it again, and it should say, I'm going to type in the wrong number, and it says you lose. Okay, so I tested both paths through the program. Whenever you have if statements or something like that, and you're testing your program, you need to test both options. And testing is kind of an art that you learn. Typically, when you're a programmer, like in a class like this, you test your program to see if it runs. But then, if you give your program to a professional tester, or you give it to a professor, he's going to test it to make it fail. Your goal is to run it and make sure it runs. My goal is to run it and see if I can make it fail. Now, I'm not going to be hard-nosed, in the beginning of the class, and if I can make your program fail because I typed in some invalid data, I'm not going to, either I won't say anything about it or I'll mention it if we've talked about how to correct it. What would be an example of something that would cause us to fail? We don't know how to accommodate this right now, but we could. What if we don't type in a number? What if we type in a name? Jeff? Well, at least it didn't blow up. In some languages, that would actually cause it to crash. But it didn't make this one crash. Okay. Alrighty, did everybody get this in? If anybody needs help getting this to compile, I want to help y'all before we go on, because we're going to make a change to it. This is really a pretty boring game. There are two things wrong with it. I kind of mentioned them already. One is that you just get one shot at it. It ought to loop over and over and over. We're not going to make that change. We're not up to looping yet. But the other, okay, I can think of three things. The other is that the guess is always the same. The secret number is always the same. That's not very fun. It ought to be randomly determined. We're also going to leave that for another day. But the third thing that we could do that would make the game better is if we said whether our guess was too high or too low. Because if we guess 10, I want to know that that's too high, so I could try a lower number. Or if I guess 4, I want to know that it's too low, so I could try a higher number. So I'm going to draw a flow chart. And I'm going to use a program called Lucid Chart in order to do this. And eventually I'll get y'all hooked up with Lucid as well so you can draw your own flow charts. But for now, I'm just going to go ahead and do this one. And a flowchart is a visual, a graphical representation. It's like a map. It's a picture rather than a source code. And since this isn't programming class 1113, we're not going to do a lot of flowcharting in this one, but it is a skill that we all need to at least be familiar with looking at. So all flowcharts start with a little command that says start. That's just, it's not a programming command, it's just like the arrow in a mall that says you are here when you're looking at the sign. I don't know what it's doing. There we go. So there's our little start, that's our you are here. What is the very first thing our program does? The first line of code after main?
Input.
I don't think it's input. Let me go look. Oh, it's these two things, where we define our variables. We will do that. To define our variables, we use a process block. A rectangle is what you use for like math. Input and output, when you use cout and cin, are instead done in that kind of block. So we're going to declare our variables. Int secret is equal to 5. And I really should put them on two separate blocks, but to save typing time, I'm going to put both of them in one. And go dump that. Int guess. Okay, now what's after those two definitions in our source? Yeah, we're doing some output, right? So in this kind of program, when you're doing a flow chart, you could either make it match line by line the code of the program, or you can just be real generic. I'm going to be generic, but if you were turning this into a program, you'd have to use a cout statement. So, what was our message? Please enter your guess. Yeah, please guess a number. Alrighty. And the reason I'm not making a cout is just so that you see that this is a series, this is the logic of the program. And you could give this to anybody, any programmer who could program in any language, and they could write it. But not every language uses a cout. So I'm being more generic than that. I'm describing it in general terms. It'd be like if I was trying to tell you how to go to Walmart and I specified that you use a bicycle. Now you might not use a bicycle to go to Walmart. You might drive a car, you might walk. So if I said drive 10 miles, that's, you may not appreciate me telling you to drive if you're walking or riding a bike. Okay, so after we use display guess a number, we need to input. So I'm going to use another box like that that says input guess. What's after our cin statement? I will put some comments here, though. We're going to use cout there. And here we're going to use cin. Put some comments just to remind ourselves. Okay. Now we have an if statement, right? Okay. So, if guess is equal to secret, if that's true, we're going to print a you win message. Input and output are done in that kind of box. So display you win. But if it's not true, then we go the other way and we display a you lose hoser message. Display you lose. Now I'm going to put the word else here as part of the no, just to remind ourselves, because there's no else keyword in flowcharting. These are logical descriptions. Yes, if this is true, go this way. No, go that way. But this is part of the else code block. So that's why I'm putting the word else there, just to remind ourselves that everything here needs to be part of the else code block. Once the if statements are done, the lines need to join back up together. So I'm just going to make a little circle, which is a place for them to join back up. And then lastly, we didn't have anything after that, did we? We had a system pause. So I'll put that in here, system pause. Which you can leave off if you're the Mac programmer. And after that, we'll put our stop command. But instead, let's actually put a return down here. Return 0. Now, I should hook everything up with lines, because if, it's not hooking up with lines, we're not exactly sure in what order things go. But I'm going to save some time and draw one line that hooks all three of these things up. Okay. There we go. So that's our flowchart for our program. If we compare our program to this flowchart, we will see pretty much a one-to-one correspondence between that and the code of our program. I'm going to paste this program into that flowchart. Now I need to be able to write justify the text, and I'm not seeing how to do that. There. Okay, so there's our program, and there's a flowchart that matches its logic. This stuff is not part of the flowchart because this is not logic. This is programming code, but it's not logic. This is for describing the logic. These are the stuff that has to happen before you start executing the logic. It's like you have to own a car or borrow one before you can start driving, but we're not going to go put into the flowchart buy a car. So instead of saying start here, I'm going to change that line start to say int main. Kind of make it match our code a little bit more. Okay, so I described a change that I might want to make to the code, which is that if we don't get the guess right, we want to tell them whether it's too high or too low. How would we do that? If it is right, we still want to display you win, so we're not going to change anything over here. But if they get it wrong, we don't just want to say, hey, you lose. We want to give them a clue as to what went wrong. So what would we do? What would we replace this with in order to display either a too high or too low message?
If statement?
We could have another if statement, yeah. We can nest an if statement inside the code block for this if statement. And I don't know whether I want to draw that first or whether I want to put it into the code first. Maybe I'll draw it first. So, if they don't get it right, we go to another if statement, and we're going to say if guess is greater than secret, guess is greater than secret, we're going to print out too high, display too high. Else, we're going to display too low. And again, I'm going to put the word else, or, in parentheses after the word no to indicate that this code goes in an else block. And those things also need to join up in a circle before we go back and join up with that one. So it's like the circle indicates a closed brace, in a way. there's our change. We added an if statement here. We print too high. If that's true, we print too low if that's not true. So if you can keep that logic in your mind, go back to our code, comment out this you lose statement, put a slash slash there. And then see if you can write the lines of code that would perform this if and these displays. I'll give you just a second to do it, and if you can't do it by yourself, that's totally cool. I will work with you on it, but I want you to take a stab at it. It's just like the if statement we already wrote.
Oh, you're using else ifs. That's also really okay, but that tells me that you have programmed it before. Because I didn't show you how to do that.
No problem. All right, guys. There's almost always more than one way to implement a program. And what I was expecting to see is this. I thought that you would do this. If, and you would put this inside the else block. If guess is greater than secret, C out too high, else C out too low. If you're only putting one line in a code block, you can usually leave the braces off. So I did see some people do that, like they would put the braces in one place and they'd leave them off in another. That's actually going to work. I could remove almost all the braces from this, but I'm leaving them in. So that's one way to solve the problem. However, you can also structure it slightly differently. And I'll show you down here at the bottom. Excuse me. You could do if guess is equal to secret, do something, and then after that you could do else if guess is equal to something or greater than, and then you could do something, and then you could do else. Maybe you might want to make it else guess is less than secret, or you just make it else. This is the other way in which you could structure it. So if you've done programming before, you probably did it like that, like you did. All right. So this is what it's going to look like. And what I was meaning by you can leave lines off if the code block is only one line long. You could leave that and that off. That means the same thing. Now this code block is more than one line, so I could not take that one away. Because this code block actually goes all the way from down there to down there. But this code block is only one, so I could leave that. I could take that out. I could take that one out. I'm not recommending y'all do this. There's absolutely nothing wrong with using too many braces. But you can leave them off if you think that the code looks cleaner. My recommendation is to go ahead and put the braces. But if I was at a premium for typing space to get it all on the screen at the same time, or if I'm in a hurry, I might leave them off. I'll give you an example of a reason why you might not want to leave them off later. I'm going to undo that change to put all my braces back. And as a matter of fact, since we're wrapping this one up, I'm going to go ahead and space it out the way I like. This is known as the block programming style, when the braces line up with the keywords above them. All right. Anybody need help getting this to work?
Yep.
I'm going to space this one out. Debug. Yeah, we don't want system pause here. That's only for the last line.
So we don't want it to pause and say too low, because earlier, if we got it right, it just disappeared.
Right, we want the pause to be at the very end of the program.
Okay.
So we actually want it to be messed up. Right here. And you're right, you could scatter it like you did, but really we only need to do it in one place. All right. The only problem is that you had an occurrence. If we put this line back to where it was, and I should show this to everybody up there on the screen, then it thinks that this is the code block for the if statement, and it thinks that this isn't part of the code block for the if statement. So it's like, it looks like that, and then there's an else suddenly appearing out of nowhere to confuse it. So if you have more than one line after an if statement, more than one statement in a code block, you'd need to put the braces there,
Yeah.
like that, and that would work. Let's go ahead and take that. Does it make sense why I'm putting all those, whoops, all of these pauses? I took them all out and just put it at the bottom. It's because no matter what it prints, it's still going to hit the pause at the end. I'm not sure why when you ran it, it didn't do it that way to begin with. But hopefully it will.
Now with the pause, just like we just right
Yeah.
there.
Yeah.
Show up.
Sir. Alrighty, we don't have our # include and are using namespace up at the top. So go up to the top of the program and add these two lines.
Oh.
That'll get you going. Got yours?
Yes.
Will do.
I did have it working a second ago, but I was trying to,
Do what I did up there and I broke it.
I was trying to fix it so it looked cleaner, but now it's kind of. Oh no, it says something
Go ahead
like
and compile it. Oh, it's showing the error there.
expected expression.
That's because we have a closing brace here without an open brace there. So we need to get rid of that one.
Oh, so does that end in, okay, so, okay.
Because this else is entirely one block. So I recommend actually leaving the braces in, but I did see people leaving them out, so I wanted to mention to everybody. Y'all all got this going now? Got your stick on. I don't see errors. Go ahead and run it and show me what it does. Well, this is called .h. We need to rename the file to be .cpp.
Oh.
Give it another well, I don't know what it's doing. Let's do build, clean solution, build, rebuild solution. You may want to deleting this and adding it again. Let's copy all the text if that turns out to be necessary. Alrighty, so we're gonna move all this. Get a copy so it's not lost. Now we're gonna come back over here. We can, I was expecting to see .h. I'm not seeing .h there. Same version. Add new item. Okay, there. Now I didn't see it before, but it's there now. I'm gonna just leave it source.cpp rather than rename it. Paste it. Now let's do it. Rebuild solution. It actually compiled it. We see our message there now. Alrighty. Okay, guys. So we did this program. The one that I want y'all to do for homework is the age to enlist in the military, as far as I understand it, is between 18 and 42. If you're younger than 18, you can't get drafted into the Army. If you're over than 42, you're safe from the draft. Not that we have a draft anymore, you know. But we're going to write a program that will display either too young or too old or go enlist. So it's going to look a lot like this one. It's going to look almost exactly like this one, really. So as a matter of fact, I could just copy the logic for this one and paste it into a new flowchart. Or I could draw it again, but really? No. Okay, so we only need one variable for this one. It's going to be called age. I guess we could have a min and a max variable as well. That might be kind of cool. So let's do that one. We're going to need a variable called min. It's going to be 18. We're going to need a variable called max, and it's going to be 42.
Do we need to save that last one we did?
Yeah, go ahead and save that one. We'll make that an in-class assignment. This is going to be a new program that you write, but it's actually homework. You could, of course, just change the one that you're doing, or you can create a new project for it, which is what I would recommend. So instead of displaying please enter a number, we're going to display please enter your age. And then we're going to input the age. If age is less than minimum, we're going to print too young. Else, if age is greater than max, we're going to display too old. And if our age is not less than min and our age is not greater than max, it's perfect. So we're going to display perfect. So you can get the idea based on how much typing I did, which is really not very much, that you could do this program really, really quickly. But I am going to assign it as homework, so you could do it at home, or you could just, do it right here, right now if you wanted to. So putting these flowcharts into a Word document, this first page is our in-class assignment, which we've already done. And then the homework will be the second flowchart that we drew. So we got up to but not including 2.6 in our PowerPoint. We will make 2 drop boxes in Dropbox in Dropbox E. That's the in-class one, which is the guessing game. There it is. And then homework 2 will be where you should upload the version that does the age. And both of them are in the same file, so the file is just uploaded into 2 different places.